Homework 2, Problem 1. Find the electric field inside a uniformly charged sphere with charge density ρ0. So to do this, I'm going to use the integral form of Gauss's law, which states that the flux through a surface, so integral d2x n hat of the electric field, dot E, is going to be equal to the volume integral, d3x, over the charge enclosed. For our system, the Gaussian surface that we will be interested in will be a sphere that is smaller than the charged sphere. So if the green here is the charged sphere, then our Gaussian surface is going to be a smaller sphere inside that. And we're going to define that smaller sphere at radius r. Now, the normal to the surface of the smaller sphere, this n hat, is going to be simply the r hat vector. And for reasons of symmetry, we are going to be able to state that the electric field is only going to point in the radial direction and can only depend on the distance from the center. So the electric field as a function of the radial vector r is going to simply be the electric field r in the r hat direction. Finally, we're going to be able to, with these two things, we can make the identification that n dot E hat can be rewritten. So the left-hand side of this equation up here can be rewritten as the integral of d2x of ER, the function of r. This is simply the surface area of the sphere, and so this is going to be 4 pi little r squared E sub r of r. The right-hand side of this equation up above is going to be very easy. Rho is a constant whenever we're inside the surface, so that factors out. And so the right-hand side is going to be ρ0 times the integral d3x. And the volume here is simply 4 pi, or 4/3 pi r squared. So this is ρ0 4/3 pi r cubed. I'm missing an epsilon naught there. So let's get an epsilon naught, epsilon naught. So dividing 4 pi r squared epsilon naught over, we get that the electric field in the radial direction must be then ρ0 over 3 epsilon naught times r. And then identifying this condition here, we can recover that the electric field vector component is ρ0 over 3 epsilon naught, and we're going to make the identification, right, that r hat is equal to the vector, so this is going to be r vector.